Good morning, class, and today we're going to go over the second example in our multi-step problem notes. Let's take a look at this problem and get started. A 3 kilogram book has 38 newtons of force applied upward for 2 seconds. How high will the book go after the applied force stops? This seems like a short and simple problem, but it definitely has two parts. Because if I tried to re-summarize this problem, I would say the book is being pushed upward, and then the book flies through the air like a projectile. And in these two situations, there are different forces being applied, so I need to separate this into an and then situation. So as before, I'm going to begin highlighting my values, and I'm going to color code it. Yellow is going to be the book being pushed upwards, and green is the book flies upward like a projectile. 3 kilogram book applies for both situations. The 38 Newton force is only being applied while the book is being pushed, and that 2 seconds is also when it's being pushed upward. Now our question of how high will the book go is a question that happens in our green, or when the book flies through the air like a projectile portion. So if I started looking at my green portion and trying to solve for it, I'd be wondering how high the book goes. Like a projectile, projectile motion, hopefully we remember, is all kinematics. Now, just to make a little picture reminder, when something is coming up to the very top of its projectile motion, right, we're looking for the maximum height. We actually remember something about the peak of the flight is that the velocity here is equal to 0. So that's nice. We get to use the context of our situation to give us a little information. And we know that our acceleration is caused by gravity, so I get to input a value for our gravity here. And as before, you can see that I gave acceleration a negative, because it's going down, so that means I defined down as negative and I've defined up as positive. Now, two pieces of information is not enough to solve, so we either need to find the initial velocity of the book or how long the book is flying through the air. Now, there's no mention of any stopwatch or anything that will allow us to find the time, so it seems reasonable that we should be able to find the velocity of the book when it leaves the thing that's pushing it. Right? Maybe this is my little pushing device. What would be the velocity when it leaves the thing pushing it? That's something that we'll know when we are looking at the book being pushed upward. So let's take a look at the things that we know before in the book being pushed upward section. We know a mass, we know a force, 38 newtons, this is the applied force, and we know a time, 2 seconds. Now in this case, I'm actually going to try to use impulse and momentum, because I know that my impulse, my change in momentum, is my net force multiplied by my time, and that is also equal to the mass times the final velocity minus the mass times the initial velocity. Or remember, the final velocity of when the book is being pushed is the initial velocity of the book flying through the air. So that'll tell me, if I can only find this, and this is a very simple formula, especially since when you begin throwing objects, it seems pretty reasonable to assume that the initial velocity is going to be 0. So what we have to do here is let's check. What do we know? Do we know the mass? Check. Do we know the time? Check. Do we know the net force? Not yet. We'll have to take a small moment to make a free body diagram to help us determine what would the net force be. So there's an upward applied force of 38 newtons. But this is still on the Earth, so there's going to be some gravity. And that gravity we'll be able to calculate with 3, the mass, times 9.8. And that's going to be 29.4. So finding our net force here, we make a little net force equation. It's going to be my up applied force subtracted by my down force of gravity, 38 minus 29.4. That ends up being 8.6 newtons. That's all that we need now. We have the net force, we have the time, we have the mass, so we can use that to find our velocity, which will help us in our second portion. Let's plug in our values now. 8.6 newtons of net force multiplied by the 2 seconds of time will equal our mass of 3 kilograms multiplied by the final velocity minus 0, because anything times 0 is going to be 0, so we get to ignore that. All right, and to solve for VF on its own, divide by 3 on both sides. So let's bring out our calculator and find out what this final velocity for the book being pushed, or rather the initial velocity of the book flying through the air, is going to be. 5.73 meters per second. And now we're ready to calculate the height that the book flies after the applied force stops. Let's use a kinematics formula. VI, VF, A, and D means I'll use the formula VF squared equals VI squared plus 2 times A times D. So we see here that the book would fly 1.7 meters high after it stops being pushed upward. That's going to be all for us today. I hope you're getting used to summarizing the problems, stating the and thens, and being able to connect what values are going to be related across that time line that we had there, that red dashed line that separates time. That's all for today. Have a good day.